Assalamualaikum. This is my class. Okay. Okay, I'm going to the tutorial on solve this problem. Okay, very simple problem. Stated you pada telepon. It's that in a link mechanism shown below, a mechanism the crank AB rotates clockwise at 70 rev per second. It's 5 at 70 rev second constant. Okay. They want is determine the acceleration of piston C. Okay. The acceleration of piston C. Tangential acceleration of link BC and BC at this point, at point B, and the angular acceleration of link BC about point B. You should draw the space diagram and the velocity diagram accurately first lah. Yeah. So in order to solve the problem, of course, we have to draw the velocity diagram. This one, we need to draw the velocity diagram. Of course, draw the velocity diagram. Let me show how this mechanism works first. This is point C, B, and point A. Right. So it rotates anti-clockwise. So it rotates clockwise. Okay. So to solve the velocity diagram, firstly, what you need to do is you have to draw a tangential line between a tangential line of A and B line. So you have to draw like this, about 90 degree. So here is the line. Then since it rotates clockwise, so supposedly the it pointing upward. Okay. And then what's supposed to be the magnitude or the length? We don't know the length, so the formula to solve it is V equivalent to we got V equivalent to omega multiplied by R. So this omega is 70 radian per second, and then R is 80 millimeter. So 80 millimeter is equivalent to 1, 2, 3, 0.08 meter. 0.08 meter. That's why you got that. So the length is calculated to be around 5.6 meter second. 5.6 meter over second. So this is the line. So of course, before you start to draw the velocity diagram, of course you need to put a scale kind of measurement. Let's say for this one, they put 1 centimeter equivalent to 1 meter per second. Okay, so this is your first step. On your second step is you're going to draw another tangential line of B and C. So this one goes, you unjuk lah bawah pun tak apa. Okay. Alright. And then from this point, you're going to unjurkan dia. Sampailah dia intercept each other. until those two lines going to intersect each other. So this one is going to be your second step, and this one, sorry, this one is going to be your second step, and this one is going to be your third step. Okay, this line, I couldn't find uh, the other properties to draw. Ah, yeah, there you go. So this line, you're going to measure, and then somehow you're going to find it to be around 4.6 centimeter. And then together with this line as well, you measure it to be whatever uh, length is supposed to be. So therefore, you're going to get your velocity of point C and B. Yeah, of sorry. So more or less, you're going to get the velocity of this point of this point. Yeah, and then you're going to get the velocity of this point. So those 2 points you're going to measure accordingly. All right. So this is very straightforward for the velocity diagram we discussed in our previous class. Yeah? All right. Now we move on to the extension of our study. Of course, that one, 4.5 centimeter, you're going to multiply with the scale to be 1 centimeter equivalent to 1 meter, right? To 1 meter per second, right? So this 4.5 centimeter, you multiply by 4.5, sorry, my God. Highlighter, and okay, this 4.5 centimeter, okay, we're going to multiply by 1. So you got 4.5 meter per second. Okay, and then for the link B, this one, more or less, yeah, for this one, and up above, you already cover the velocity diagram 5. So settle. Okay, now we move on how to find how to find the acceleration part. Uh, and this one is not that tricky, it's quite straightforward as well. Uh, of course, nothing much changes. You're going to draw a simple mechanism like what we done previously. Okay, you got point A, you got point B, and you got point C. And here is your piston. So this one is 0.08 meter, and this one is 0.22 meter. No, sorry, meter. Okay. Oh, I got sorry. Okay. So how we going to solve it? Of course, we know our omega, yeah, or our I highlighting it. And the crank rotates clockwise at 70 radian per second. Yeah, the velocity of angular velocity is about 70 radian per second. Yeah. So 70 radian per second. So same goes. We're going to equate 70 radian per second by this time, since it goes by radial acceleration. So the omega need to be squared, and then you multiply by the radius, which is eventually to be 0.08 meter. Okay. Okay, so by this time, your 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 acceleration is calculated to be 392 meter per second squared. Yeah, 392 meter per second squared. Okay, and then for this case, oh, sorry, for this case, for link BC, okay, the the radial acceleration is found by using this equation, v squared divided by r. Okay, what is v squared? V squared is our angle, and sorry, v squared is our velocity. Yeah, uh, this velocity. Wait up. This velocity. Okay, which is found to be 4.5 squared here. 4.5 squared. This velocity. Yeah. So 4.5, you're going to square it since according to the equations, and then you're going to divide it by this length or r, this length, which is 0.22 meter. Therefore, you're going to get the what you call that? You're going to get the you're going to get the acceleration to be 92.05 meter over squared over second squared. Yeah. So these two is what calculatable. Okay, these two is you want to manage to calculate. Yeah. All right. So now this is quite tricky part. Yeah. How we going to get this kind of diagram? Okay. Basically, the diagram is quite straightforward. I'm going to draw again. Yeah. This is our mechanism. This one A, this one B, this one C, of course. Okay. All right. In order to draw, yeah. Okay. In order to draw, we're going to set the scale to be 1 centimeter equivalent to 80 meter per second squared. Okay. So we know this one is you know clockwise. So we start going to pointing downward. So we draw this is tak cantik. So saya cantikkan. Subhanallah. So we're going to draw this one. Saya padan dulu lah. Tak cantik lah. Okay. 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 So this one. Okay. We're going to draw the line supposedly parallel. So, dia selari dengan point BA yang asal ni, link asal ni, the initial link. Okay, for the acceleration diagram, the line supposed to be parallel. And what is the magnitude or the measurement of the line? The measurement of the line is supposed to be 4.9 centimeter. Where you manage to get 4.9, this is where you get it. Okay, tak cantik. Okay, 392 divided by 80. So you're going to get 4.9. Same goes like this. 92.05 divided by 80. So we managed to get like about 1.1 plus something. 4.9 cm. This one 1.1 cm, something like that. Okay. So this is where you manage to get your 4.9 centimeter for this line of radial acceleration at point BA here. Okay. And obviously this is going to be your first step. Your second step, basically, it's quite what I call it, it's quite straightforward as well, where you're going to draw uh, a parallel diagram of BC, at the end of this line. You're going to draw a parallel diagram of BC with the magnitude to be around 1.2 centimeter. Okay, here 1.2 centimeter is coming from the calculation, the radial acceleration that we calculate, 92.05 meter over square second. And then, of course, our scale to be around 1 centimeter equivalent to 80. So this is where we managed to get the what you call it, the magnitude. And of course, this is our second step to calculate the acceleration diagram. Okay. Okay, so far I think maybe you can follow it slowly. All right. Now we go to our third step. How are we going to draw this tangential CV line? Okay. Basically, this tangential CB line, you're going to draw it this way. Okay. You're going to draw it that way. So, here is the line. Okay. And of course, from the starting point of the line, you're going to draw another line like here. Okay, more or less you're going to extend it further a bit, and then this one you're going to extend it further a bit. Okay, so those intersection line is the end of the line of tangential acceleration, and then acceleration of C. So you're going to afterward, this is going to be your third step, and this is going to be your fourth step. Okay. Saya lebih lawa, no worries. So more or less, you're going to use your protector or ruler or whatever you can. You're going to measure. This line need to be measured. This line need to be measured. Okay. So once you measure the line, then of course, you got 4.3 centimeter for AC. Yeah, here for AC, you're going to get, you measured somehow, maybe you got like about 4.3 centimeter, then you multiply by 80, since this is our scale. Okay, 1 centimeter equivalent to 80 meter per second squared. Therefore, you manage to get, oh my goodness, you manage to get 344 meter per second squared. And then for the acceleration CV, you manage to measure to be around 3 centimeter. And then of course 3 centimeter multiplied by 80, you got to get 340 meter over second squared. Okay. Yet since this is a tangential acceleration, of course you need to convert to be linear acceleration. So this is the formulation that you need to obey. Very simple. Alpha equivalent to acceleration tangential over R. Okay. So same goes like here. So at the end of the day, you're going to get your wait up. You're going to get your acceleration of C is about 1090 radian per second. Okay, so that's all from me. Somehow we managed to solve the problem. Yeah, question 5 from velocity diagram up to the acceleration diagram. So more or less, this is what covered for chapter 2. Yeah. So hopefully you can follow all my instructions lah. My instruction to solve this kind of problem. Of course, you cannot do on your own if you don't. If you cannot catch up or it's quite struggle for you to understand, then I don't have any problem for you to find me at my office. Quite free for this week, so please do find me, and then maybe we can discuss. But at the first initial stage, I think maybe you can start to solve this problem part by part, point by point, and then we see how does it go. Okay. Up until then, till we meet again. Assalamualaikum warahmatullahi wabarakatuh, and good luck. Bye bye.